Welcome to CodeCrucks. In this video, we will talk about set theory. I'll be talking about introduction of the set, which are the different methods for representing sets, what are the different types of sets, and at the end, we will talk about the applications of the set theory. Set is nothing but it's a collection of unordered and distinct objects, which are called elements of the set. So set is having two important property. One is elements are unordered. That means if I write set A as 1, 2, 3 or 3, 2, 1 or 1, 3, 2, all make same set. The another important property is distinct objects. That means you cannot repeat elements in the set. So if I define some set as a 1, 2, 2, 3, 1, then it is not a set because elements are not distinct. So these two properties set must hold, unordered and distinct. Broadly, we can classify sets into two categories, finite sets and infinite sets. Finite sets are the sets in which number of elements are finite or they are fixed. For example, A is equal to 0, 2, 4, 6, 8 or B is equal to 1, 4, 9, 16, 25, 36, 49. So as we can see that in set A, there are 5 elements. In set B, there are 7 elements, which is countable. So these sets are finite set. In infinite set, number of elements are infinite. For example, A is equal to 1, 2, 3, 4, 5, which is set of natural numbers. B is equal to 0, 2, 4, 6, 8, and so on, which is set of even numbers. So we cannot fix how many numbers are there in A and B. We cannot make that count, so that A and B are called infinite sets. Elements in set might or might not have relation between them. If we consider S1 is equal to 11, 22, 33 as a set, we can see that there is a clear relationship between elements. All elements are multiple of 11. So if elements are having certain relations, then we can easily write it using mathematical notation like S1 is set of all the elements X such that X is equal to 11 into K, where K varies from 1 to 3. So as we replace value of K into this formula, we will get different values of X and we can build the set. So this is a set builder or the property method for constructing the set. We will talk it very soon. But if we talk about S2, so S2 contains three things: colors, fruits, and subjects, which are not related. They do not have any relation. S3 is equal to red, truck, X99, Pascal. So all 5 elements are distinct. They do not have any kind of relation. Red is a color, truck is a vehicle, X represents some variable, 99 is a constant, and Pascal is some string. So you see that set elements may or may not have relation between them. Set contains another set as its element. Here S1 is equal to A comma B, and C, D comma I. So this S1 contains 3 elements shown in different colors. And as you can see that A is an independent element, but AB set in red color and CDE in blue, they are set itself. So set can also be the element of another set. S2 is equal to A, B, and C. So this this definition is recursive. You can define any sets within the another set. Okay, you can have this nested structure up to any level. The membership of element is denoted by belongs to sign. We can also read it as a belong to or is member of. So if element is present into the set, then we will say that element is member of set or that element belongs to set. In this particular case, A does not belong to BCD set. In this case, 3 belongs to 1, 3, 5 because 3 is present. But for this case, 3 doesn't belongs to set 1, 2, 3 because 2, 3 is a one element of the set. But 3 is not independent element or the single element. So we can say 3 is not part of this set. 5 here is not part of 1, 2, 3 set. But if we have an explicit element 5, then it can be the part of the set, or we can say it's a member of set. Let's talk about cardinality now. Cardinality of set is the number of elements in the set. So it gives us the size of the set basically, that how many elements are there into the set. That is what the cardinality of given set. If we start with A is equal to null or the phi, there is no element into this set. So we can say that cardinality of set A is 0, and cardinality is typically represented by mode A, or the set name between pipes. Here set B contains only one element, which is A, so cardinality of B is 1. Set C contains two elements, A and phi, so cardinality of C is 2. Very straightforward, D is equal to ABC, so cardinality of D is 3. Here, though there are in total 3 elements, but AB is a one set, which is one element of set E, and C is the another element. So cardinality of E would be 2, not 3, mind well. Similarly here, F is equal to set of ABC. So ABC is one element of set F. So cardinality of F would be 1, not 3. And similarly, G is equal to A, then B, then we have some elements in blue color, some elements in red, and C. So I have color coded, so we can understand that okay, each color represents one element of set G. So total number of elements might be more, but the size of G or the cardinality of G is 5, because it is having 5 elements only. Let's talk about various methods for representing or writing the sets. The very simple method is a statement or the descriptive form method. Well-defined description of set is given in this method. So many times mathematically we cannot write the set, or we cannot represent the set based on certain characteristic. So we can give the statement or the descriptive form of the method. For example, A is equal to top 3 programming language, which might be Python, Java, C, etc. The second method is listing or roster method. In this method, we are exhaustively writing all the elements of the set. And this method we use when there is no relationship between the elements. For example, height of the students in the classroom, weight of the students, or maybe performance of the students. So we can say B is equal to 5 feet 6 inch, 5 feet 8 inch, 6 feet 1 inch, 4 feet 9 inch, etc. And the most popular and the most powerful method is a property or set builder method. When elements share certain common characteristics, in that case we can use this method. For example, set C is equal to all the elements X, where X is less than or equal to 100 and X belongs to set of natural numbers capital N. So the set contains elements 1 to 100. Right? So we don't need to write down all the elements one by one. We can just provide this mathematical representation X, where X less than or equal to 100 and X belongs to N. So this is quite compact and very powerful representation. And most often people or mathematicians use this method to create the sets. Let us talk about various types of set. The first one is a null or empty set. So set which does not have any element is called a null set or empty set, and it is represented by empty curly brackets or the symbol phi. Singleton set is a set in which there is only one element. For example, this is a null set. There is no element, so it is not a singleton set. Here, phi is the element of set. That's why it is a singleton, because it's the only element. 1, 2, 3 is not singleton because there are 3 elements, and 1, 2, 3 in curly bracket within the set is a singleton because 1, 2, 3 is the one element of the outer set. So if you find the cardinality of all 4 sets, then first set has cardinality 0, second set has cardinality 1, third set has cardinality 3, and fourth set has cardinality 1. So in other words, we can say that set is a singleton set if its cardinality is 1, or there is only one member in the set. Universal set is a set of all the elements. So if we are given multiple sets, then if we take the union of all those sets, it can form universal set, or we might be given universal set explicitly. If it is not given explicitly, we just have to take the union of all the sets into the consideration. And when you take the union of all the elements I is equal to 1 to n si, then it forms the universal set. And typically we use symbol capital U or capital X to represent the universal set. And sometimes it is also referred as a universe of discourse. We can say A is a subset of another set B if all the elements of A are present in B also. So mathematically we can write A is subset of B if for all X, if X belongs to A, that implies X must be in B as well. Then only we can say A is subset of B. And proper subset. So we can say A is a proper subset of B if A is subset of B as well as there exists at least one element in B such that it is not in A. So in case of subset, A and B both set can be same. But in case of proper subset, set B is larger than set A. There will be at least one element in B which is not in A. So we can write A is a proper subset of B such that A is subset of B and there exists some X so that X belongs to B and X is not in A. That is how we can mathematically represent it. If we consider phi, then phi is subset of any set including itself, and phi is the only set that does not have proper subset. In the same way we can define the properties of superset and proper superset. Let us take the example. If we have a set A is equal to 1, 2, 3, 4, 5, B is equal to 1, 2, 3, 4 and C is equal to 1, 2, 3, 4, 5, then for subset following conditions are true. B is subset of A, B is subset of C. That's very obvious because A and C both contains all the elements of B. Set A and C are identical, but still we can say A is subset of C and C is subset of A by the definition of subset. But when we talk about a proper subset, only B is proper subset of A and B is proper subset of C. But as there is no additional element in A and C, then their counterpart, we cannot say that C is proper subset of A or A is proper subset of C. That is not true in case of proper subset. And in the same way, if we talk about a superset, then A is superset of B and C is superset of B because both contains B. Similarly, A and B are identical. So if there are two identical sets, both can be superset of each other. So A is superset of C and C is superset of A. But if we talk about proper superset, then only these two conditions are true. A is proper superset of B and C is proper superset of B. A is not proper superset of C because there is no additional element in A. And same is true for C. Power set is a set of all the subsets of given set and it is denoted by either P of A or 2 power A. And the cardinality of 2 power A is same as 2 power cardinality of set A. That means if A is equal to ABC, then power set of A will contain all the subsets of A, and we have already learned earlier that null set is subset of all the sets. So phi will be definitely member of any power set. Then we will add subsets of size 1 from set A. So that would be set A, set B, set C as shown in red color. Then we will add all the possible subsets of size 2 from set capital A. So that will be AB, AC and BC as shown in blue color. And then we'll add the subsets of size 3. So any set is subset of itself also. So ABC will be the subset which will be the part of power set. So as we can see, there are 3 elements in set A. So power set of A contains 2 power 3, that is 8 elements. If B is null, then power set of B contains phi because phi is subset of every set. C is equal to a set containing element phi. So power set of C would be the null set or the phi will be definitely member of any set, and then we will add the element of C into the power set of C, that is a set phi within the set, that is shown in red. D is equal to element phi and set phi. So power set of D would be first we have to add phi by default, then we have to add all the subsets of size 1 from D. So that will be phi within the curly bracket and the set phi within the curly bracket. Right? So try to understand these concepts of curly bracket, where to add how many curly brackets. So we have formed two subsets of size 1 from D. Now we will add subset of size 2. So we have two elements, so both will be added. That means we are adding the set itself as a subset. So power set of D contains 4 elements. Let us talk about one more example on power set, that find 2 power AB. So 2 power AB, that means the power set of AB. And again we have to take 2 power of that. So we have to find power set of AB. So let us first compute this red part, that is 2 power AB, that is the power set of set A comma B. So by default, phi will be definitely the member of all the power sets. Then we will add set or subset of size 1 from the original set. So we have a set A and set B as a subset of size 1. Now we will add subset of size 2. So that is set itself, because it is having only 2 elements. So we are going to add the fourth element as a comma B. So now there are 4 elements into this set. We have to find power set of that. So as there are 4 elements, the power set will contain 16 elements, because 2 power 4 is 16. So first one, we have to add elements with size 0, that is phi. Then we will add all the subsets of size 1. So all the elements from the original set, we will put it into the set format. So that is phi, we have to put it into curly bracket, then A in curly bracket, set B in curly bracket, and set AB in curly bracket. So these 4 are the sets of size 1. Now we will be adding subsets of size 2. So we will take all the possible combinations from the original set and we will add them. So phi comma A will be 1, phi comma B, phi comma AB, then A comma B, A comma AB, and finally B comma AB. So these are the subsets of size 2. Next we will add subsets of size 3. So that will be phi A B. That will be one subset. Phi A AB would be the next subset. Then phi B AB would be the next subset, and A B AB would be next subset. Now we will add subset of size 4, that is set itself, because set contains 4 elements. So we will be adding the entire set as one of the element of the power set. So as we can see, there are total 16 elements into this power set. The applications of set theory is very vast. It is widely used in mathematics and computer science. For example, many mathematical concepts like graphs, manifolds, rings, and vector spaces can be precisely defined using set theory. All the number systems like set of natural number, set of real number, set of complex number, they all are using set to represent the numbers. Set theory is also foundation of many mathematical branches, specifically like discrete mathematics, and it is used in many abstract algebra problems as well. And here comes testing of your learning. Please post your answers into the comment box. The first question for you is, give example of 2 finite sets. Any 2 finite sets you have to write down into the answer. Next question is, give example of any 2 infinite sets. The question 3 is, find power set of A is equal to null. Next question, find power set of set A is equal to A, comma B, comma AB. And the last question is, which of the following are singleton set? So from A, B, C, D, E, you have to mention which one is the singleton set. If you are not confident enough about your answers, then please visit the link given in the description box where all answers are mentioned. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.